There has been an explosion in the AI-based semantic search apps all over the internet. We also built one such app in one of our content using TypeScript. With that being said, you can extend this AI-based semantic search to other contents like HTML documents. And that's what we're going to build today. We are going to build an AI-based semantic search app to talk to our HTML documents. For the purpose of the tutorial, we will use Shadcn UI's document section, that is an HTML document, and we will build our app in a way that we can simply talk to the HTML document and ask anything that we want from the document. Just a side note, we're not going to build this app from scratch like I did with my Chat with PDF app. Rather, we're going to clone the code of the PDF Chat AI SDK and build on top of it. If you want a deeper understanding, I would highly recommend you to watch the other video first and then come and watch this video. With that introduction, let's get our hands dirty. Let's break down the video into subsections. First, we're going to talk about the problem that we have with existing AI-based semantic search app. And then we're going to build the architecture of the app. And after that, we're going to build the data collection layer for our app. And then we will build the first iteration of the app and see how it works. Then we will make a small code change in order to improve the search results. And then finally, we will build our last iteration of the app to chat with our HTML documents. The problem with AI-based semantic search apps lie around data quality, which directly impacts the search results. When you build a semantic search app, you typically prepare a knowledge store with the data that you collected from your PDF documents or your websites. This data is usually collected by loading or scraping your file and splitting the text content based on some fixed number of characters. Although this type of text splitting can work for text-heavy content, if we do the same type of text splitting on HTML document, we may not get the desired result. So what's the answer? Instead of splitting the text on fixed number of characters, we're going to split them based on title or subtitle and the text content that comes underneath that title or subtitle. This allows us to store the entire chunks of text with their context intact, and these are called context-aware text chunks. Context-aware text chunks offer a better data quality, directly improving the search results of a vector database. We will see more details about this in the next section. If you have seen my Chat with PDF content, you would have seen this architecture where we have the first step to split the chunks and prepare our knowledge store and store the chunks inside the knowledge store. Once our knowledge store is ready, we use our Langchain's LLM chain sequence to talk to our database and use the information from the database as a context and make the LLM answer the question. This app that we are building is going to be around the same architecture, with an exception that we're going to use a Python library called unstructured.io for data collection and chunking. So why are we using another language? Because this unstructured.io library is not available on JavaScript yet. So that is the reason why I'm using Python. This Python library would enable us to scrape our HTML documents and split the documents into context-aware chunks. Once done, we will pass the information to our vector database and do the same LLM chaining to first get the information from a knowledge store and then use that information as a context and make the LLM answer the question. As I've said before, for the data collection, we'll be using Python. And I myself am not a Python expert, so I'll be using Python only for this step, where we will prepare a JSON data to feed into our Next.js app. I've used a Google Colab notebook so that you don't really have to set up a Python environment locally. You will also have a link to this notebook in the description below. For those who don't know what Google Colab is, it's a free Python notebook online and you can run Python code easily. We can split the code into two parts. First, we will load the website and collect all the URLs from that page, and then we will use those URLs to load all the HTML pages and collect the data from all the HTML pages. Here you can see that I've installed some requirements. So I've got two libraries that I'm installing. The first one is called BS4. So this library will load the HTML for us, and then another library to make the request. So what this code does is it loads the docs HTML page and collects all the anchor tag links and saves them in a set so that it can remove all the duplicates, and also filters out the URLs that points to external page like Facebook, Google, etc. Once done, we dump them into a text file, and if you run this code, you should get a text file that contain all the URLs under this document and should look like this. The root document is going to be docs, and all the other files are going to be segments on top of this path. In the next step, I'm using this text file that we prepared and loading all the HTML content and splitting the chunks by title. And I'm actually converting the chunks into the format that is required by Langchain's document type, and also storing it inside an all groups array. As we store the chunks, I'm also using URL segments to prepare a title information to put inside the metadata, which we will use later. This is how we convert our URLs into titles. So for example, if the URL is docs theming, then it's going to be theming. And if it's docs components accordion, then it's going to be accordion components. And if it's just docs, then we're going to keep the title as summary. Once we processed all the URLs, we have an additional step to collect the titles, remove all the duplicates, and store them in a variable called unique titles. And we take this unique titles and create a new chunk under the title summary and add it to our all groups array. Why do we do this? We do this so that we have a map of all the available pages in this HTML document. It's a simple way to improve the data quality so that the language models have all the information to answer a question. Finally, I use a titles array and the all groups JSON array to prepare a data.ts file. This data.ts file will be used inside our Next.js app to populate our vector database. I've already run this piece of code to prepare my data.ts file. Let's quickly copy this file and format it and see how it looks. As you can see, it's got the titles information, which we will use later. And we got the JSON data information that we prepared from our HTML content. And what we will do is we will take this JSON data and we will pass it on to our embedding LLM and store the information into our knowledge store. Now that we have our data ready, let's see how we use this data to build our app. The app is going to be fairly similar to our PDF Chat AI SDK app. So we will have to simply use the same code base that we use for the PDF Chat AI SDK. And the tech stack is also going to be similar, apart from the Python library and the data collection step that we have. I'm going to quickly clone the code base that you see right here and copy the data.ts file into the scripts folder of the code base. After we clone the code and copy the data.ts file inside our scripts folder, it should look pretty much like this. So this is the data.ts file and we have the data, and our code base should look pretty much like this. So the first thing that we're going to do is we're going to adjust the AI experimental and turn this into an AI. So for example, we no longer need it to be AI experimental. It can just be this AI. What I'm going to do is I'm going to do a quick npm install. And also I'm going to do npm install AI. In the meanwhile, I have an index called test index. I'm going to use my data.ts file to populate this index. So for that, I'm going to go into my script folder. I no longer need this PDF loader. So I'm going to take this down completely. And I'm also going to take it down from my lib. So this is not required anymore. And I'm going to import the data as docs from data.ts file. So this docs is a new data for us. What we will do is we will simply run this script and see if it works. Right before we do this, we have to populate our end file. So I'm going to copy this env example and I'm going to rename it to env. In that env file, what I'm going to do is I'm going to remove the Pinecone namespace and PDF path. So I no longer need these two items. The namespace is no longer supported on the free tier. So that's the reason why I'm going to remove that. And the rest, I'm simply going to copy all the information that I have at hand. So these are my personal API keys. So you can also fill your own API keys. I'm going to switch them up. So don't worry, you can't really copy them. So this is how the .env file should look like. With this, I think we can go ahead and run our npm run prepare data command. All right, so there is something wrong, and that's a good thing. That's complaining. So now if I go ahead and run this command, seems to be working. So I'm loading 216 chunks in my Pinecone index, and I've got a namespace and I've got 216 chunks. Great. So this is working as expected. So now let's clean up the code base a bit. All right. So the next thing that I'm going to do is I'm going to do some cleanup. So for that, I'm going to go into my components. And inside chat, I'm going to remove the AI stream experimental and change it to AI because all the latest updates are available on the AI SDK itself. So there is no need to install an experimental SDK. I also have this inside Langchain.ts file. I'm going to update all this information. Now I come back to chat and I've got initial messages. That should be inside utils. That should be aligned with our document. So I'm going to update that. That looks good. Now I want to go back to chatline.tsx. And instead of a formatted text message, I want to support Markdown. And what I'm going to do is I'm going to use React Markdown. And instead of trying to format the text, I'm just going to simply pass the content. And I no longer need this formatted message method. And also, I will no longer be needing this converted lines method as well. So in order to support a proper Markdown colors and the code blocks and tailwind, we have to install something called as typography plugin. So what I'm going to do is I'm going to quickly install the typography plugin from Tailwind. And once done, I need to add this to my plugins list. All right. Now what I can do is I can simply add some extra classes in order to support both prose and dark prose classes. Cool. So this is number one. And number two is that I don't want accordion anymore. Rather, I want badge links. So I want to be able to click on the badge and then it should take me to an external link. So for that, we have to first install a badge component from Shatsian UI. All right, so that's done. I'm going to add a simple badge component and it will pass the source onto the href and also use the same source in the anchor tag. All right, so this looks pretty good. Now we have to adjust the data that is streamed from the Langchain. So if you go to the then method inside langchain.ts file, we have to adjust what data we send back as part of the stream data. So right now we stream the page contents and this will be shown in the accordion for the PDF chat AI SDK. So for us, what we're going to do is we're going to simply send the source URL. So what's the source information? So this is the source information. And we use the source information and stream this data back to the client side. We also remove all the duplicates that we have and we send back the source information. Now, if you go back to the chatline component, the sources information would be an array of source URLs. And we no longer need this component, so I'm gonna remove them. Everything seems to look good, so we have to see if this works as expected. So I'm gonna do an npm run dev. So this is gonna be our first iteration of the app. All right, so we're gonna ask a simple question. How do I install and use alert component? We would assume that this would fetch the data from the knowledge store and pass it as a context to the LLM and give us back the information. Yeah, so looks pretty good. You can see that everything is working as expected, and we also get the external links. If we click, it's going to take us to the external link. So we have all the information that we need. And we're going to ask another question. Yeah, it seems to be working as expected. Now we're going to make it a bit more tough. We're going to start asking a bit more ambiguous questions. Can you summarize the document? So let me refresh and then ask this question again. So you can see that it's not trying to pick the summary, rather it's trying to pick the information from typography. Somehow, some questions, we don't really get the right answers because of the fact that it's not really targeting the right places. So this is a real problem, right? You may not face this problem in all cases, but in some cases, you may face this problem. So for example, if I ask this question, is this a component library? Yes, it's a component library because it's trying to get the answer from about, but it should not. Rather, it should get the answer from introduction. So here is where we're gonna implement another technique in order to get the right answers. In order to improve the search on a vector database, so we have another interesting thing called filtering with the metadata. What happens is that when you request something from a Pinecone vector database, you can also pass the metadata as part of the query. That's exactly what we want to do right now. For that, we're going to add an extra LLM chain in order to get filter information from the question. So this is my approach. I mean, you may have your own approaches in order to improve the search, but what I've done right now is that I have implemented a simple step that tries to get the metadata from the question. So we are going to use the language model to do the job for us. So if I go back to the code base, I'm going to add an additional template in our prompt template. And I'm going to use the all titles. Let me explain you what this template does. You are an expert text classifier. Your job is to generate an array of strings that are within the context that best match with the input question. And I'm asking you to check all the titles that we have. That is all the titles that we have here. And asking the language model to check the question and also match which titles suit the best for the question. I think this is called few-shot prompting. In the few-shot prompting, you kind of give the information, some examples to the language model, and it's gonna give an output based on that. For example, if the input question is gonna be, can you summarize the document? Then the output is going to be summary about. And if the input is going to be how to install alert component, then the output is going to be alert components and installation. So I am actually trying to guide the language model to give an output for me. So this would essentially give back the title in array format. I'm also trying to guide, hey, if the user is trying to ask something irrelevant, then you give back an empty array. And my input question is going to be on the same format, and the output would be based on these inputs. So this is not a foolproof way, but it's still my interesting technique to give back the answers that I want. What are we going to do with this information? We're going to go back to the vector store. I'll be using something like this. So for example, I want to look for the matches in the title, and in the title, I'm going to check for these two matches, summary or about. Simple. So that's what I'm going to do. So this information that I'm going to get from that LLM, and I'm going to pass this information as part of the metadata filter. So this would give me the answer that I need. Let's set this up. I'm going to go to Langchain.js and use the prompt that I've just made. For example, I have this prompt that I have to import from prompt templates, and also I have to import LLM chain. I'm trying to prepare a prompt template from the prompt template that we just made in the template file. and we're going to pass it to prompt, and then we're going to make a chain. So we're going to name it as metadata filter chain. And what I'm going to do is I'm going to call this chain with the question. So what I'm going to do is I'm going to pass the question inside this chain, and then I'm going to try to get the answer from the chain. So let's see if this actually works. Obviously, this is going to make your chain a bit slower because now there is an extra request that needs to be made to ChatGPT. Now I'm going to ask a question. Can you give me a summary? So this would essentially take this question and pass it onto the new chain that we've just made and give us back the output in an array format. It's still giving the old answer, but then if I go back to the code and then check if there is a metadata filter, I'm going to check for the metadata. Yeah, you can see that it gave us back summary and about. We're going to pass the metadata.text, and inside our vector store, we're going to go into the vector store. I'm going to call it title filter, and I'm going to use a title filter to prepare our filter. So now you can see that we are passing the title filter using json.parse and then passing it to this method. Once that's done, I'm going to pass the filter down to my vector store. Right before we go further, I also want to tell you one really quick thing. We have also updated the QA template a bit. After we've updated our QA template, we're going to give our chat a buffer memory. So let me go ahead and give this a buffer memory. So I'm just going to add a simple buffer memory, and I'm going to import the buffer memory from Langchain memory. So yeah, so with this, our app is complete. So now in the next section, we're just going to run the app and see how this works. Now that our app is complete, we're going to test the app just to see if this works as expected. So I've got a list of 10 questions that are a bit hard to answer and see if it does the metadata filtering properly based on the questions and also give us the right answer. So since there is an extra chain, there's going to be slightly time consuming. Let's see how it works. So first question is going to be, give me a summary. It's able to pick the right information from the database. So let's see what's happening. So if I show you what's happening, it's picking these two filters, summary and about. So that means it's going to go through the data and check for summary information and then just get all the information that's under the summary. So what it's going to do is it's going to just pick up all the information that's under the title summary. And also it's going to pick up about both. Let me ask another question that failed in the past. This is a component library. Here you can see that, no, this is not a component library, blah, 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 and it's a collection of components. So how is it able to answer that? Because of the filters that we just applied. So for this one, what's the filter? It's going to be summary. And it's just taking the answer from the summary and then giving us the answers. I'm just going to ask, what's this document about? So yeah, it's still going to hit the summary and then get back the information from the database. And if I click on the link, it's just taking me to the right place. Now I'm going to ask a bit more tricky question. So what are the FAQs? And it's given me the right answer and also where I can find the FAQs. So now let's ask a bit more easy questions. How do I install alert component? All right, it's answering the alert component question properly. Now I'm going to ask, how do I build a login form? So this one should typically look for the form component. Let's see if this answers properly. Okay, so it's kind of answering as expected. Let's see what's happening here. So after I ask for form components, it knows that, all right, so this guy is asking about form components. It's using this form components as the metadata filter and getting all the information from the form component. So That's the reason why this works. Let me ask a question. Is there a frog component? So the frog component is not a part of the picture, and it should just tell me, no, there is no mention of the frog component, blah, blah, blah. So I'm going to ask another question about build an e-commerce cart component, and it should give me an answer. Cool. So it's working as expected. I'm going to give you an example of one edge case where it may fail. What are the list of available components? So here you can see that it's giving me a list of all the titles that I've added. But then the problem is it doesn't really know what are components and what are just normal files. That's one problem that I can think of. But for most parts, it should be able to give you the answers that you expect. And also it should be able to understand, what's happening. Yeah, so that's practically it. So this is the AI-based HTML document search that's built on top of Langchain and Next.js. Thanks for watching this video. If you liked the video, please leave a like and subscribe for more, and I will talk to you soon.